Welcome to MyProjectBazaar.com. If we discuss about the process, the capacity of wireless CSMA bar CA networks. Let me discuss about the abstract of the project. Efficient discovery and effective sharing of spectrum opportunities are the most challenging issues in a multi-channel cognitive radio network with multiple secondary users. Distributed opportunities spectrum access scheme based on sequential channel sensing in decentralized CRN cognitive radio network. Different from the traditional spectrum sensing scheme, the scheme proposed allows a secondary users to sense many channels one by one sequentially in a slot. Opportunity spectrum access based on sequential channel sensing in decentralized CRN. Simulated annealing is a probabilistic technique for approximating the global optimum for a given function. Specifically, it is a meta-heuristic for approximate global optimization in a large search space. It is often used when the search space is discrete. The SA heuristic considers some neighboring states of the current states and probabilistically decides between moving the system to states and staying in states. These probabilities ultimately lead the system to move to states of lower energy. This approach jointly addresses when to perform sensing, which channels to sense, in what order, and how long to scan each channel. Let me discuss about the flow diagram for our process. Initially, the parameters has been initialized. Next, generate the channel matrix based on the base station, primary user and secondary user. This is the system model. A one-cell wireless system where the PU and SU transceiver coexist in the same geographical location is assumed. The scenario is investigated for a downlink path and KCR users. Primary users base station transmit signals to PU primary users, each of which occupies a determined frequency band in the available spectrum. The CR network has an individual base station that identifies the spectrum holes on the basis of the collected information about the spectrum, then deactivates primary user subcarrier and transmits its users information on the remaining subcarriers. Next, the subcarrier allocation. In a single channel communication system, the de-amplification and loss present on them can be simplistically taken as attenuation by the percentage. Then amplifiers restore the signal power level to the same value at a transmission setup by operating at a gain. If we experienced 6 dB attenuation in transmission, 70% loss will be occur. Then we have to amplify the signal by a factor of 4 cross to restore the signal to the transmission level. The search for a proper subcarrier allocation for CR network is inspired by the optimal user selection for subcarrier. Next, the power has been allocated. By allocating a specific user for any subcarrier in conformity with the proposed metric, the optimization problem becomes similar to one optimization problem for a single CR user case. Finally, the capacity maximization. With regard to the results and assumption proposed in previous section, the problem of maximizing the capacity in the downlink path can be formulated. If the interference will be less than threshold, then maximize the capacity of assigned user. Finally, we analyze the performance graph based on the capacity maximization with the help of water filling algorithm. In order to compare the performance of newly proposed algorithm with the previous ones fairly after determining the proper power for each branch by the Lagrangian based algorithm in each iteration. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, write the file and run for executing this process. Here we analyze the capacity maximization for our CSMA CA networks. In these networks, we improve the capacity based on the primary and secondary user settings. After estimating the performance graph, we come to the conclusion for our capacity maximization. In this process, we estimated the saturated mode and unsaturated mode. Based on that network, we analyze the throughput and capacity of our system. Here we obtain the graph. This is the connectivity between every users, and this is the channel coefficient values, and this is the FFT transformation, that is Fourier transformation, and this is the consumption power at every channel, and this is the graph for saturated mode. This red color represents the ideal mode, and this white color region represents the buffer status, and this blue color represents the transmission mode, and this is the unsaturated cases, and this is the dual saturated network for the unsaturated network, and this is the normalized throughput. By varying the link index, we analyze the normalized throughput for the values of rows equal to 0.75. This is the normalized throughput for the values of rows equal to 0.5 by varying the link index for existing system, and this is the normalized throughput values when varying the row is equal to 0.25. This is our proposed system, and this is the our existing system for our rows equal to 0.25, and this is the rows equal to 0.05 values. For our proposed system, we obtain the normalized throughput, and this is the normalized throughput for our existing system when row is equal to 0.05, and this is the normalized throughput when rows equal to 0.01 for our proposed system, and rows equal to 0.01 for our, and this is the capacity graph between proposed and existing system. By varying the iteration number, we got decreased response in the capacity, and this is the normalized power in watt between our existing and proposed system by varying the iteration number, and this is the sensing time for our various channel. Finally, we increase the capacity for our saturated and unsaturated mode using our CSMA bar CA networks. Thank you.